All right, welcome to section 4 on composite functions. We've got part A, part B, and part C, it looks like here. So let's dive in. Question 1 asks us to find the f of g of 1. I just want to be clear that this notation could also be written as the f of g of 4, something like that. That's the same thing. Notation f of g of 4. So we're going to start with the inside. Right here, we're going to find the g of 1. And that output, whatever output's there, will become the input to f. So the g of 1, I'm going to show it in detail on the first one. I might take some shortcuts down the road. I'm substituting 1 into all of these x's for g. So the g of 1 is equal to 1 squared minus 2 times 1 plus 4. So the g of 1 equals 1 minus 2 plus 4, which equals 3. Because 1 minus 2 is negative 1, and negative 1 plus 4 is 3. Now, that 3, the g of 1 is equal to 3. So let me just write that right here. The g of 1 equals 3. They are the exact same thing. That means the 3 can substitute into this g of 1. And so this really is asking us as, what is the f of 3? Well, that means I'm going to substitute 3 into function f, which is 4 times 3 minus 5. And the f of 3 is equal to 12 minus 5 is 7. So the f of g of 1 is equal to 7. All right, let's hop over here to the g of the f of 0. So I'm going to substitute 0 into f. The f of 0 equals 4 times 0 minus 5. So the f of 0 is equal to negative 5. And that negative 5 becomes the input into g. So the g of negative 5 equals negative 5 squared minus 2 times negative 5 plus 4. So the g of negative 5 equals 25 plus 10 plus 4. The g of negative 5 equals 39. Okay, the h of k of 2. So I'm going to substitute 2 into k. So the k of 2 is equal to 3 minus 2 times 2. That means the k of 2 equals 3 minus 4, negative 1. That becomes the input to h. So you get the h of negative 1 equals 3 times 2 to the negative 1. And now you got to know your laws of exponents. This stuff doesn't go away. You just got to be good at math to be good at pre-calc. 2 to the negative 1. Well, that is equal to, a negative exponent means it's in the wrong place. So 1 over 2 to the first. 2 to the first is just 2. So this is really 1/2. So it's really saying, what is 3 times 1/2? Well, you could call that 1.5. You could call it 3 over 2. It doesn't matter. All right. Okay, so now we have the f of negative 1. So I'm going to take the f of negative 1. So 4 times negative 1 minus 5. F of negative 1 equals negative 4 minus 5 is negative 9. So now I'm going to take negative 9, and I'm going to input it into f again. So let's do that. The f of negative 9 is equal to 4 times negative 9 minus 5. 4 times negative 9 is negative 36, minus 5 is negative 41. So we get negative 41 here. All right, now I got the h of 0. So where's h? H is here. So the h of 0 equals 3 times 2 to the 0. anything to the 0th power is 1. So this becomes 3. Let me just show it. 3 times 1, which is obviously 3. So now I'm going to input 3 into h. So we get the h of 3 is equal to 3 times 2 to the 3rd. And 2 to the 3rd means 2 times 2 times 2, which is 8. And so the h of 3 equals 3 times 8, or 24. All right, the g of k of 4. So I'm going to input 4 into k, and then I'm going to input that output into g. So the k of 4 is equal to 3 minus 2 times 4. The k of 4 is equal to 3 minus 8 is negative 5. Negative 5 becomes the input to g. Oh, we already input negative 5 into g over here. We already did that over here. So we just know this is 39. I'm going to just take a shortcut. G of negative 5 is 39. Already did that math. Okay, the h of f of 2. So the f of 2 is equal to 4 times 2 minus 5. 8 minus 5 is 3. And I substitute that into h now. Didn't we already substitute 3 into h? Look, we already did that here. They're making our life easy. The h of 3 is equal to 24. All right, now we're going to get a little funky. We're going to input 3c into f. So we're going to end with an algebraic expression here. So where's f? So we get the f of 3c is equal to 4 times 3c minus 5. And what does this simplify to? It's just going to distribute this. We get 12c minus 5. Now I got to take all of that and input it into g. Okay, there's not enough space for this. So the g of 12c minus 5 is equal to 12c minus 5 squared minus, we're just going to leave it like this, 2 times 12c minus 5 plus 4. You could simplify this. I hope you do. I don't have the space for it, and I don't want this video to be too long. So I'm just going to, if you need this answer, go ahead and pause it. I'm about to erase it. 3, 2, 1. All right. Let's move on over here. Same thing. This is going to be a long answer. We'll just set it up. We're going to input 5a plus 4 into k. So k of 5a plus 4 is equal to 3 minus 2 times 5a plus 4. That's going to simplify to 3 minus 10a minus 8. I could combine like terms. 3 and negative 8 make negative 5. So it's negative 10a minus 5. And then this becomes the input to f. So f was 4x minus 5. So the f of negative 10a minus 5 equals 4 times negative 10a minus 5. What is it, plus 3? Minus 5. And so, all right, we can finish this one. Distribute. And we get negative 40a minus 20 minus 5. We get negative 40a minus 25. All right. Now we have composite functions. We just insert the g of x into the f of x. Again, our answer is going to be an algebraic expression. So g of x, this whole thing, goes into the f of x. So we get 4 times x squared minus 2x plus 4, x squared minus 2x plus 4. And I still have this minus 5 at the end, and I just simplify this. I mean, I don't know. I would accept this answer. It's factored out. This seems nice. This is right. This is correct. You could also write it as 4x squared minus 8x plus 16. Drop down this minus 5, so 4x squared minus 8x plus 11. That's also correct. Just simplified. Okay, g of f of x. So we've just switched the order this time. This time f of x is going into g. So we have x squared, so that'd be 4x minus 5 squared. And then we have minus 2x, so 4x minus 5. And plus 4. Again, you could simplify this, combine like terms. We just don't have the space, so we're going to stop with that answer. And the k of f of x. So putting the f of x into k. So 4x minus 5. So k of f of x. So we have 3 minus 2. Instead of x, we have 4x minus 5. This one, fine. We'll just simplify it. 3 minus 8x plus 10. Combine like terms. Negative 8x plus 13. All right, so that's a lot of practice with composite functions in part A. Part B, we want to look at their graphs. The graph of a function g is given if h is given by the function 3x plus 1. The graph of function g is given if h is given by the function 3x plus 1. Sketch the graph. Okay, interesting. So sketch y equals the h of x, the g of the h of x. So we're putting this into g. So what we're really doing is we're multiplying all of these major points here. We're multiplying them by 3. And then we are adding 1. So I have this point here, negative 2, comma 3. I'm just going to kind of move this over. So I'm going to put the g of x over here for a second. 1, comma 2. Sorry, 2, comma 1. And so what I'm doing right now is I'm putting these major points. I'm just redrawing g of x over here. Then I have 5, comma 4. And what is this? 9, comma 4. Okay. So here's g of x over here. Oh my god, it just crashed out. That is annoying. All right, let's go all the way. Let's just quick do that again. We're at negative 2, comma 3. We are at 2, comma 1. 5, comma 4. And 9, comma 4. Okay. So let's connect those together. All right, so I've brought the g of x over here. We want to sketch this. And so, yeah, we got to multiply by 3 and add 1. So let's multiply by 3 to this output, negative 2. The output was 3 right here. So I'm going to multiply that by 3, go to 9. Add 1, that's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 right here. Okay. All right, now this output right here is 1. So I'm going to multiply this by 3. 1 times 3 is 3. Then I'm going to add 1. So that ends at 4. 1, 2, 3, 4. 4 is right here. Sorry, this is a bad video. I'm sorry. My brain is a little fried. All right, here we're at, what's our output? 4. So we're going to multiply by 3 and then add 1. 4 times 3 is 12. We're all the way up at like 13. Sorry. It's kind of a bad video. Same thing up here. And it's going to look something like this. All right. Yeah, there's some things on here that are a little bit tricky and maybe not that well done on my part. And I apologize. Made this over Thanksgiving break. Okay. All right. Tables. Tables are very important with these. We've got the g of 0. So let's start by finding the g of 0. So when x is 0, what is g? It's 0. So the g of 0 equals 0. Now I'm going to input that into f and find the f of 0. So when f is 0, what is the output? It's 4. So the f of g of 0 is 4. On this one, our input is the f of 1. So let's find the f of 1 is -2. F of 1 is -2. So now my -2 becomes the input to g. When I input -2, what's the output? It is 0. So the g of -2 is equal to 0. All right, now we have the g of -2. The g of -2. So let's go to -2 on the x. What's g? Is 0. The g of -2 equals 0. And then I'm going to take that 0, input it into f, and we get 4. The f of 0 equals 4. All right, let's hop down to this one. We got a new table. We have the f of -1 inside of g. So the f of -1 is equal to, when x is -1, what is f? It's -2. And when I input -2 to g, the g of -2, that is equal to 0. The g of 1, the g of 1 is -2. And the f, so the g of 1 is -2, and the f of -2 is 3. Last one, we have the, I'll use green, the f of 2. So let's go to 2, is 4. So the f of 2 equals 4. And the g of 4 equals, oh look, we do not have enough information. There's no g of 4 on this table. So not enough info. All right, that concludes section 3 on inverse functions. Section 4 on inverse functions. On composite functions. See you on section 5, which is